cool. So let's start out. So I guess done in examples 1, right? We're done with this. We don't need to do a full recap. Okay, cool. So what are types? I think we actually covered types very, very briefly last time. So let me open, because I think we wrote something down. Yeah, we wrote this down in main, right? What's going on with this extension here? Right, so we wrote this thing down, right? So let me paste this here, right? So we said that strings are written like this, and then ints are written like this. Well, and then it would be nicer to do like this, like not, because we don't want to think that integers are only up to 100, right? And Boolean values are true and false, and then numbers necessarily have a dot, right? And so on. Okay, cool. Well, this is triggering me because this needs to be here. They need to be ordered. Okay, cool. So one thing to note here, one important thing about syntactical note that I've mentioned earlier is that types are always capitalized, right? So like string is capital S, int is all of them are capitalized, and then functions always start with a lowercase letter. You could also have like functions are also like signs, right? Operators. So that's fine. Yeah, we'll get into type variables later. I don't think I'll explain when we get to type variables, but yeah, you're right. Okay, cool. So then let's see. Strings are a bit special, and they have special syntax. So we will not look into them a lot right now. But then numbers have this thing, right, where you have a lot of ways to create numbers, right? Basically, for all the numbers, you can write like a character or some sort of thing for them, right, to create a number. So let's see. One thing that's important, notation, basically, is that we can say, so how should I say this? So values always have types. So let's think, what does this mean? Have a type, I guess types is correct. So basically, what are values, right? Values are things that you can operate over, right? You can return values, you can print them, maybe usually or sometimes you can do operations over values, right? So you could do something like 1 + 1, right? That's an operation, and 1 are values, and then this plus is a function. Interestingly enough, functions are also values, because as we've seen in here, like we pass a function here to another function, right? Just like we pass an int. So functions are also kind of like values, which is pretty interesting. But like you can do operations over values, right? But any value has a type. So how do it denoted by value type, right? So this is how we will write when a value has a type. We'll write it like so, right? Value : and then the type, right? So for example, right? So we have A is string, right? ABC is string. 1 is int, 2 is int, etc. So we're kind of writing the same thing below, but using the different notation, right? Which we'll use a lot, right? True is a Boolean, false is a Boolean. 1.0 is a number, 1.5 is a number, etc. Right? So we'll remove this because we already wrote the same thing here using the new notation that we will be using from now on, right?
Yeah.
Okay, cool. So then so let me make Boolean, let me move Boolean side, right? So here, like similarly to math, you kind of have an infinity number of strings, ints, and numbers, right? That's okay, give me 1 second, please. So one thing, I don't use trigger to mean bugging me or upsetting me, because it should be reserved for logical triggers. Using it like you viewer makes it harder for people experiences triggers to talk about their experiences and be taken seriously. I don't know how to explain it any better right now, but it's really bad to misuse it and send shivers down through my body when somebody does misuse it. Okay, sorry, I didn't know that. I'll make a note and try to be careful. Okay. So I'm sorry about any discomfort. Sorry, I might have caused. Yep. I try to be careful. I literally didn't know. So thank you for letting me know. Okay, cool. So let's see. So where I was going. So I was saying that strings and ints and numbers are all like infinite. We know that there's quite a few of them, right? But then booleans are only two values, right? And this is interesting, and we'll talk about this a bit later. But I just wanted to mention it right now, right? So basically, what I'm trying to say is that there are no other booleans than these two booleans, right? True and false. We can say, for example, we can introduce a new boolean. We could say it is a boolean and it equals false, right? We can do this in PureScript. Let me do this thing. Oops. Right. Yeah. And it's this is absolutely correct, but this is it's not a new value, right? Because it's actually the same as false, right? So it's it's a synonym. We could say that it's a synonym for false, right? But it's not really a new. It's also a new value, but it's not a new. Yeah, well, thank you very much for saying that, Luna. That means a lot to me. I'm trying my best, and I plan to do some things regarding that soon. Like I've seen today a stream. Sorry, and I'm taking a very, very short detour here, Andrew. Sorry. I saw a stream earlier with somebody else from the FP community talking about their like prejudices and. But he was only focusing on racial ones, and I thought that we could do something similar at some point, but maybe consider all of the others, because I don't think I wish they were talking about all the others as well. So yeah, maybe you and maybe other people who are watching the stream could help me make this stream better, because one of the things that I think I don't have a good I need to improve is when you type the first time you type in chat, you get a message, and I think it's a very short message with that will be a long stream. Oh yeah, of course, we won't be able to get everything right in one stream, but maybe we could start with just having a very good, well thought out message for when somebody first joins chat, right? Because Twitch gives me the option to have a message for, hey, before you type something in chat, look at this, like read this first, right? And I think I have something that's very, very short and not very descriptive. I think it's kind of fine, but I want to make that better. So maybe we can write something better there. That makes it clear that we're not tolerant to intolerance, basically, and well, whatever else we think that might fit there well, and give a good idea of what kind of stream people need to expect, and the fact that I will really not tolerate any sort of hate or whatever. So anything like that. So yeah, we can do that sometime later this week or something. Cool. Okay, let's get back to teaching. Okay, so cool. Okay, so basically what are types is, what I wanted to say here is there are basically two levels in which when we write PureScript, and this is kind of similar to other languages, but then in PureScript and languages like PureScript, this is the like, it feels like this is a very clear distinction, right? So we usually always write a a type declaration, let's call it here, like on top, and then we write the body, basically, right? So basically what we're saying here is like what we can write here is usually only things that are like types and type constructors and so on, and we'll see how this works out. And then here is the value level, right? So basically here we can write things that you'd write on the right hand side of this thing, right? Strings and ints and numbers and booleans. And then on here on the right hand side of this equals, we write values like 1 and true and a and so on, right? Does that make sense?
Yeah.
Okay, cool. So what are types? Well, types are, first of all, you can look at types are like maybe sets of values, right? Because like Boolean is a set of two values, true and false, and then number is the set of all numbers, and then int is the set of all integers, and string is the set of all strings, right? And of course, these are infinite sets, and this is a finite like 2-item set. We'll see how we can define our own sets, which only have like maybe we add 3 colors to a set, or we add all kinds of other things. But that's the main idea, right? So basically, types help us, and you've had some C#. You have some C#. Numbers also include plus, minus, infinity, and not a number. Yeah, I think so, because of how JavaScript works. I think number also includes those. Right. Where was I going? Okay, so you had some experience with C#, so you're somewhat familiar with types, right?
Yeah.
So you already know that types help you write less mistakes, right? Because in n-type languages like Python, I think you've done a little bit of Python, if I recall correctly.
Yeah, but for I'm still ongoing.
Yeah. Okay. Cool. No problem. But like, even if you've done a very little, you've probably noticed that it's a bit harder to always know what's happening, because if you don't have types, then you need to be a lot more careful. Like you kind of have to run the type checker in your head and think, okay, that's a string and that's an int, and I need to do that over that, and I need to convert it like that. So you're kind of, since they're not explicit in the code, or the compiler doesn't help you, then you have to basically have a mental compiler or mental type checker that helps you realize that, okay, I need to pass, I need to convert this to something else, I need to do this, and I need to do that, right?
Yeah.
Cool. So that's types, right? So we use types in order to make it easier for us to read things. And in functional languages, we not only use types like and in Python you're always wrong. Yeah, maybe. I'll be honest, I don't think I wrote more than a few lines of Python ever. I know enough languages to not have to learn Python specifically and to be able to just type some out, and it kind of works. But yeah, I managed to dodge it for so far quite successfully. Right, so where was I going with this? Right, so you can have okay, so they help us not make mistakes. Okay, and in functional languages, this is where we're going. I got back the train of thought. So in functional programming, where we basically define types, and we define a lot of types, and we try to be very specific and very precise with the types, right? Such that we get better and better error messages, right? So if we like whatever we're trying to build, we'll try to define a type that is very precise to what we're trying to do, right? So if we want to only use a subset of numbers, then maybe we define a type that can only accept those subset of numbers. And if we want to define, I don't know, like whatever we do, we try to be very precise with types, and you'll see that as a theme throughout me teaching you and throughout a lot of libraries in FP and so on. Okay, so I guess this was also the basic types recap, because we also talked about this basic types. I deliberately did not talk about function types, and those are also types because I want to talk about them here, right? So we will not cover them right now. We'll kind of skip this. So okay, let's see how we define our own types. The very, very basic idea here. And we'll start with types that are only wrapper. So what does wrapper mean? So let's say we want to define our own type that's kind of like bools, but it's not called bools, right? So right now they will not really be necessarily very useful, but I want to get the idea of how this thing works. Okay. Right? So and yeah, you're good. That's one way to do it. That's definitely one way. But then if you only have a very small subset of numbers, then you can literally just define a sum type of like 3 numbers if you only want to allow 3 or 5 or 10. If it's a very small number, then it's probably easier to do a sum type. If it's like a lot more, then you probably want a smart constructor. Yeah, you could do a recursive. But then if you do recursive, then how do you bound it to a subset? I mean, it could work if you want to like only multiples of 2, right? And then you can make your own structure that represents like if you have an inductive rule, then you can also do recursive substructures. But if there's no simple inductive rule, then you probably need a smart constructor with a maybe. Sorry about that. I was just answering chat. You'll learn about that soon enough as well. Cool. So let's see. Let's define our own wrapper. So the first thing is the keyword data, right? Using the keyword data, we'll introduce new types, and I'll deliberately not teach you about new type yet because that's an implementation detail. We'll talk about it a bit later. So it's data, so let's call it my bools equals. So basically, using this syntax, we what happens? Okay, let me do something like this. Let me do this first, and then we'll see. Okay, so we have this thing here. So let's see what this means. So when we write this, data is a keyword, right? So this is just something you type, like kind of a class in C# or public or whatever, right? So this is just a keyword. It has to be there, right? Okay, then my bools is a type, is a new type that we just created, right? Okay. And then create my bools is the constructor for my bools. And we'll see immediately what the constructor is, right? For now, we're just defining what everything is, right? And then, and actually that's it, right? That's everything that we're creating right now. And Boolean is an argument for this, and we'll see what that means, right?
Okay.
Cool. So what happens here basically is that we basically introduced a new, and I think I'm saying basically a lot. Yeah, it's a data constructor. That's correct. It's a new type. Yeah, it's a data is a data constructor for my bools. Yeah, that's better. That's more correct. Type constructor is something else, which we'll get into later. Okay, cool. So data is the keyword. So my bools. What does it mean that my bool is a new type? Well, it means that we can have a value of my of type my bools, right? Just like we have true of Boolean or one as an int, we can have something of my bools, right? So this is how we create a new thing that lives in the type level. And then after the equal sign is how we create things that exist at the type level, at the value level, right? So create my bools is basically a value, right? A value that could be used to create my bools. And since this has an argument called Boolean, then so let's see. Let's add something here. Create my bools is a function from Boolean to my bools. So what does it mean, right? So create my bools requires you to pass it a Boolean value. That's what this means here, right?
Yeah.
And then it will create something of type my bools, right? So what does it mean? Then we have the following new values. So we have create my bools true of type my bools, and then create my bools false of type my bools. Right, so exactly like we have true and false as booleans.
Yeah.
We have create my bools true and create my bools false as two bools value, right? So for every boolean we have one value for my booleans, right?
Yeah.
Does that make sense?
Yeah.
Okay. Cool.
I do have one question.
Sure.
Like in real life practice, like when you make a real app, like can you use this to, like, what do you use it for? Like, do you insert? Can I use it to insert all the types of bikes in it?
All the types of what? Can you say that again?
Of bikes.
Bikes.
Like,
yeah. Sure.
Or what?
Sure. Like for example, so let's see like a good example for this.
So instead of the false and true, I would have like BMX, mountain bike, and all stuff like that.
That's a sum type maybe, and we can use that as an example for sum types.
Okay.
But so right now what we're talking about when we're trying wrappers, so when defining wrappers, we only wrap an existing type, right? So we were wrapping a Boolean or a number or an int or a string or things that already exist, right? And then we'll see and this obviously feels a lot less useful than creating your own 100% custom type, and we'll see how we do that later with these three things. But for now, we're just focusing on the basic syntax, and we'll be using this syntax for all of the others, right? Okay, cool. So then let's try to write some functions using. Maybe we should go to PureScript for a bit. So let's add a new module, which we'll call part 2, and then let's do module part 2 where, and then let's just define this again. So my bools equal to construct my bool. No, I will not go into new task because I don't think that's an optimization detail that we'll go into later when the types are clear to Andrew. So let's do boolean, and then we can say some value or my true, we could even call it, is construct soft type my bools, and then my true equals to construct my bools of true, right? And this should compile. For some reason it's let's try restarting, or let's try building maybe. Let's try restart. Oh wait, it doesn't work because I don't have my... Okay, it actually does work, but I was trying to use my Vim keyboard shortcuts here, which don't work obviously. Okay, cool, so this does work. Okay, so I think right now we need to go into pattern matching just so it's clear how we use this sort of thing. So let's do a short detour to pattern matching. Okay, so let's start with bools, right? So we've seen that we can use ifs for bools, right? But actually you can do something other than doing ifs. So let's say we want to write a function. So let's ignore my bools for a second. Let's write it here, right? So let's do pattern matching here. And let's say that we want to do a function that some conditional, that we give it a boolean and then it and 2 strings. We've written this before, right? It returns the first string. So if this is true, it returns the first string. If this is false, it returns the second string, let's say, right?
Yeah.
So we know that we can do like count S1 and S2, and we could go if count, then S1, else S2, right? We already know we can do this. Okay, but let's try something else. So we could do this. Well, this is a very poor choice of, let's do predicate here, or boolean, because then it's very confusing, right? Okay, so one other thing we could do is we could literally type true here. Okay, so we could type true here, and then we can try like this string here, and then this string here, and then we can do S1 here. And then we can type false here and then say S2 here, and that's it. So what happens here? So again, it's clear to you that this goes here, like this is the boolean, like the order.
Yeah.
That's clear, right? Okay.
Yeah.
So we're kind of saying, okay, so if this boolean is true, this is what we're saying. If this boolean pattern matches with true, then reserve it here. If it doesn't, then you fall back to the next option. So this is okay. If this is false, then it goes here, right?
Yeah.
Also, we could do something silly, like we could say, okay, but there's one more. So, okay, so let's say if condition, then first, else second, right? This is the logic here, right? But let's do cont prime, a different function.
Okay.
Which looks the same, but we'll say, okay. If string 1, if first is hello, then return hello, right? Else this, right?
Okay.
Again, it's a silly example, but it works well what I'm trying to say here, right? Yeah. So then we can say, okay, then we need to do this thing first, right?
Yeah.
Okay, so maybe here we could just say, okay, so for any boolean, if this is hello and this is whatever else, then we return hello. And you can also actually do this as well. Okay, and then the rest is the same, so we could just copy this thing over. But again, we need to write this correct thing, so it's the prime here, right?
Yeah.
So then this also works. So do you see how conditionals work? Sorry, how pattern matching works?
Yeah, I think I do. So basically, this just asks. So I get the boolean,
Mm-hmm.
and then the string, which is the hello, and if it's hello, then it strings hello.
Mm-hmm.
Otherwise, it just goes to the second one. Right?
Give me 1 second. Is it okay if I find like an initial thread on Twitter that I send it to you so that you can learn about bigotry and... Yep, yes, please do. Please do. I also retweet stuff like that from time to time. Yeah, I do read. That's how I like, from you and other people that I follow, I do try to read all of that. So, yep. But please do send something. If you find, like, if you know for a good thread or something, please throw it my way.
It could be useful to put it on chat as well, right?
Well, I'm not sure that maybe Luna's planning to do that later or tomorrow, because I think she was going to bed, so I don't want to like stress her out to have him look for it right now. But whenever you can, we can share it at some point on stream. So
yeah, that's what I meant. Yeah.
Okay, cool. So what's happening here is like, okay, so this is kind of like a condition, right? So ignoring this, right? So if this is like any time really. Okay, cool. Well, maybe we can read that together on stream when we do the stream I mentioned, where we try to write a better chat message for like chat welcome message. Maybe that's when we read about that thread and like get informed a bit better, and then we write the message. Maybe that's a good time to do that as well. Okay. Anytime really. Okay, cool. So again, what we're doing here is like, this will only happen when the first string is literally hello, right? This only matches in that case, right? If this is hello with a space or anything else here, then this will not trigger, and then it will go into either this or this, right? So this doesn't get called, and then it goes here or here, right? So is it somewhat clear? And then we could even say, okay, but then if the second one is whatever else, and a world, then we return world or whatever. Okay, yeah, please do. Cool. Okay. So hello, the return. Okay, good. So now we know how to do pattern matching, right? So let's go back here. So now let's say that we want to do. Let's say we want to write this thing, so cont, but we want to do my cont that uses my bools, and then string to string to string. Okay, and we want to do literally the same thing. All right, we want to say if, because again, so what are the values for, like, what are my, it's either false or true, right?
Yeah.
So we could write the same thing, right? So we could do, but the question is, how do we pattern match here? And the answer is like so. Okay, so instead of pattern matching, so we're looking here, right? We're comparing this with this, right? So instead of just saying true, we also pattern match with the name of the constructor that we used, right? So basically, this is how we construct a myBool value.
Yeah.
And this is how you pattern match against it, right? So you say, okay, myBools is something that's constructed using this constructor, and then it has a value true or a value false. Actually, a simple example is like my bools to boolean. Okay, and then we do construct my bool. So we write the well, it doesn't. Okay, it's here. We do this, and then we do b, right? here, right? So like when you construct my bools with a B, okay, give 1 second. So you might get a lot of different points about different stuff too, just anything I really find. Okay, cool. And then confirm that use of trigger is okay, as in it will trigger that action. It's better than not describing something that's not actually a trigger. Okay, cool. I get it. Right, so basically, like, you don't have to, what I'm trying to show here is that you don't have to literally type true and false. You can also bind it to a variable name here and then return it.
Yeah.
Okay?
Yeah.
Cool. So again, we can do this sort of thing where we pattern match on this construct or on a constructor, and then we get the value out of it, right? So this is literally getting the value out of it, right? So my bools wraps a boolean, and then this is how we get it out again, right? This is how we. So okay, let's do the opposite. So boolean to my bools. Sorry, my bools. And then boolean to my bools, b equals to construct b. Does it make sense?
Yeah.
So these are kind of like reverse operations, if that makes sense, right? Because you can go from boolean to my bools and then from my bools to boolean, right? And kind of, you can think of it kind of like an onion, right? Where you create a new wrapper on top of it, right? You wrap the booleans inside my bools.
Can I just ask something?
Yep, please do.
I keep thinking of this. I keep comparing it to the example where I asked you if I can give C the value of something that I calculated inside the function. Is it a stupid, like...
can you repeat it? Can you say that again?
Yeah, the one... Wait, I'll even show the part of the code. Yeah, this one.
Let me scroll down a bit.
Where I asked you if I can take the value of C outside.
So no, so nothing can ever escape a context, right? So for example, let me think. So for example, you could do something like, no, I don't even know how to do a good example here, but no, so you cannot,
okay.
you can't ever like pass variables around or things like that. You can declare something in one place and then use it in a different place.
Yeah, that's what I wanted to know. If I can use this to do that.
No, you can't.
Still no.
Okay, still no. Okay, so we're back here. So we talked about pattern matching. Let me I'll just paste this example for pattern matching in the markdown file, just so we also have it here. Oops, it's this. Okay, let's do so it then highlights things nicely. Oops. Okay. Okay, so pattern matching is kind of like deconstructing in a way, and then defining types is kind of like constructing, right? So these two are kind of like opposite things in a way, right? Or complementary, or however you want to call them. Okay, so let's look at some slightly more useful types than just creating wrap.